What we do here is go back.
Hello everybody, Dog Flying a Kite here, back again with another Roblox scripting tutorial. Today we're going over pathfinding again. Today we're going to be making a zombie that tracks down players and does damage to them. So let's jump into it here. We got our DA civilian. All he's programmed to do is just walk around randomly here. He's also using pathfinding, so he will navigate through the neighborhood here and find a place to hide. And then we got our zombie over here. We got some new age R16 parts. Got some R15 parts inside of it, as you can see. The only script I have really in them is just an animation script, so it's just a basic animation script here, Roblox default. And we got our blank follow script in here ready to be programmed, so let's jump into it here. So let's define our variables we're going to be using in it. Root part. Alright, and with any AI, you're going to want to find the closest target most of the time. So let's get our find target function set up here. Define our distance. So we'll do 200 for our distance. Find our target placeholder. And then we're going to go ahead and search the whole workspace for targets. And we're going to check if they have a humanoid. Check if they have a head. So they have to have a humanoid and a head in order for us to determine them as a valid target for us. Target and head, and v.name not zombie. Okay, so if we have multiple zombies, we don't want them to attack each other, so we're just going to make sure they're not named zombie, but we'll attack everything else with a humanoid. So let's go ahead and check the distance here. So another if statement. So let's do if head.position minus our root part position magnitude is less than dist and humanoid health greater than 0, then okay. So we're gonna check and make sure the distance between us and the target is smaller than our distance, and we're gonna make sure the humanoid is actually alive. Okay. So if this is true, then we're gonna go ahead and update the distance. So the next target we have is has to be closer than the previous one. So if we run through all of the targets, then eventually we're going to get to the closest one, because the distance is going to keep getting smaller and smaller until we find the closest target, if that makes sense. And then we'll just go ahead and update the target equals head. Okay, so that's all we need there basically, and then we're going to return head or return target. Okay, so that's all we need for that function. Now we're going to do the while loop. Alright, well wait, we'll update this every 1 second, basically, every loop iteration. So let's start off with defining our head here. Okay, so head equals find target, so if it returns a head, then we're going to go ahead and run this, so if there's any valid targets. So let's see here, if head. Okay, so we got the if head here, so we're going to do the actual raycasting. We're going to do some raycasting now here. So let's go ahead and get our ray defined. Ray.new. So we got our origin point and our direction. So go ahead and get our parameters in there. Okay, so the starting point is going to be us. So our root part dot position. And then we're going to go ahead and find the direction of the head position in relativity to where we are, where our root part is. Okay, so .unit. So that formula is going to go ahead and point us towards the actual target head position that we're looking at. We'll do 200 studs as the actual distance there. Okay, and then local hit position equals workspace find part on Ray with ignore list. Okay, so we're going to go ahead and put our Ray in here and add our ignore list, which is just going to be our self. So we want to make sure the Ray being drawn from our humanoid root part, which is in the center of our character, we want to make sure it doesn't hit our arms or our torso. So just go ahead and make sure that's on the ignore list there. Okay, and now we want to do if hit then. So if we hit anything, then we're going to see if hit parent is a descendant of head.parent, then we're just going to move directly to the target. Okay, so basically all this is saying here is that if we can draw a straight line directly to our target, then there's no point to pathfind because obviously there's nothing in the way if we can draw a straight line to there. So let's do the actual pathfinding now. So else we're gonna do the pathfinding. So let's do path equals game. Okay, call our pathfinding service, and then we're gonna find path async. Okay, so we got our starting position and end position, which is going to be our root part position as our starting position, and we're going to do our the head position as the ending position, and then we got to get the actual waypoints of the path. Okay, so we got our waypoints there. So let's go ahead and throw this in a for loop now, so we can make our character follow the path. Points. Okay, and then we're going to go ahead and have our character move to the first point on the loop. Okay, so let's do human, move to points, position, not points, excuse me, p.position, and then we're going to do human dot move to finished, wait, and give it a 2-second max wait on that so we don't get stuck. So all that's going to do is wait for the move to be finished, and then it's going to allow the script to continue. So it's basically going to pause the script. It can only pause the script for a maximum of 2 seconds because we put the 2 in there. If we exclude the 2 and just have it like that, it can wait indefinitely and can hold up your script. So we'll just put a 2 so our script doesn't get stuck for any reason there. It's a safety precaution. Okay, and then we're going to check if we need to jump. So we'll do b.action equals dot path waypoint action dot jump. Then okay, so we'll just make our zombie jump here if there's something, if we need to jump for any reason. So we want to make sure the path is successful before actually following the path. So if path dot status equals to enum dot path status dot success, then we will do this. Okay, put an end. Let's just do else. Then we will just move to the head dot position because we can't find a path, so we'll just get as close as possible without an actual path. Okay, looks good to me. Yeah, forgot a position in here. This is just is descendant of. Okay, and in here we're gonna have it do a check if the path is still valid each time it loops through. So we're gonna make sure that the path ends at the actual target that we're looking at, because the target may move. So we'll need to update the path if the target moves. So we're gonna go ahead and do if number of points. So we're gonna get the last points, the ending point position, and we're gonna find the magnitude from the head position that we're trying to get to. And if it's greater than, let's say 15, then we're going to just break. So we're going to break out of the loop here, where is it, the 4v loop here, and it's going to go ahead and figure out if it sees the actual target or not, if it needs to draw another path, or if it can just walk straight to it. But essentially we don't want to stay in this if the path is invalid and it's not going to take us directly to the figure there. So let's test this out here. Okay, how's it doing? Okay. Okay. How's it doing? Okay, and as you can see, the movement of the zombie there was pretty choppy. So the way I've found to kind of get around that is we'll just put a human move too, regardless of if it's going to take the path or not. Give this a 0.4 delay so we can actually. Okay, so I made a minor typo here, so go ahead and we just want to check for hit, if hit is descendant of head.parent. Okay. Alright, there we go. So now the zombie is going to run towards the figure there. If it has a plain view of sight, then it's just going to go ahead and trace. Okay, so now the zombie can see the actual DA civilian there, and the chase is on. It runs straight there. No issues. As long as we can kind of constantly keep him moving, then that would be ideal to make it look like he's not a robot. Okay, there you have it. Alright guys, and that was a practical use of pathfinding used in our zombie model here. Of course, you can program him with attacks and whatever when it actually gets to the DA civilian. But as you can see, it gets to the DA civilian perfectly fine now. So I'd like to thank you guys for watching. Stay tuned for more. Please like and subscribe. See you in the next video.